Okay, now let's have a look at electric motors. We've been looking at a complete system here, particularly interested in brushless motors, but we will just have also a very quick look at brushed DC motors. Let's concentrate on our main one though. First of all is a brushless motor. They come in different sizes, obviously, different speed and power ratings. I'll pull one apart so you can have a quick look. This one here was a kit that we wound ourselves. I would never use it now because it's mostly broken. Inside we can see the copper windings which are energized. Remember, that's my three leads coming from my speed controller. Okay, plugging directly into my speed controller. So it's DC coming in from the battery into the speed controller, AC coming out. What it does, it switches the power to these windings very, very quickly. So at some particular stage, certain windings are energized in a pattern and they become magnetic or magnetized. And then on the inside of the bell, this is the part that rotates, that essentially a propeller is attached to, are magnets arranged around the inside. These ones have fallen off and you can see that they've become stuck there. You can super glue them back on there if it happens, but I'm not going to bother with this old motor. So what happens is these windings become energized, the current flowing through them, and they will rotate quite rapidly to the and when they're attracted to the opposite polarity magnets in here. Quite strong. If you ever pull the motor apart, watch out, they'll snap back like that. Brushless electric motor. You look inside, immediate thought is, where are the moving parts? There's no pistons going up and down. There's no oil. There's just a couple of bearings there, and at the back end it's fallen out. There's my shaft, and that bell rotates around there, and there's no contact between the magnets and the energized coils. So it's brushless. There's no brushes. There's no physical contact in here. I look inside while it's running, I can't see any little sparks as it arcs like in a brushed DC motor. Okay, so quite efficient. I think figures up around 80% are quite good. There is loss in heat, obviously. There's nothing like, no such thing as a 100% efficient motor, but we're looking for high numbers for efficiency. So if I put a certain amount of energy in, I want to get as much of that energy out in terms of performance. My propeller would attach on this propeller adapter. My propeller would attach there if it was a drone or an aeroplane, and that whole outside bell spins. So it's got a fair amount of torque because this outside bell has got mass and I'm spinning it, therefore it's capable of powerful work. You can get brushless motors where the inside spins and the outside is stable, and the inside's connected to your shaft, and they're probably faster motors. So numbering, this one here, I can't read it. This one here, this motor here, you can see the outside bell rotates, is a 2836-2350. First number is to do with the stator. Stator is a stationary part. Remember, this is not spinning. So it's the stator. And inside this motor here, it's the stator is 28 millimeters wide and 36 millimeters in height. 28 wide diameter in this particular motor, and 36. Obviously, this would have different numbering. Okay, the stator is the diameter is a lot wider, and it's quite short. Different performance, different thing. The last number there is the kV. kV is basically a figure that talks to RPM per volt. This one's a 2350. It's quite high kV. This one here, I think, is around about 1000 kV mark. It's got more torque, more power. It'll spin a larger prop, but spin it more slowly. This one will be spin a smaller prop quite fast. This is a Scorpion motor. It would be a fairly high kV. They're probably up around the 2200, 2000 kV, can't really tell. Okay, good quality. It's had better days. Okay, there we go. I've pulled that apart, so that one doesn't work anymore. Again, magnets around the inside, energized coils there when I plug it in. Now, back to kV. It's how many RPM capable of per volt. So let's just say this is a 1000 kV motor, and I put one volt on it. Okay, so it's RPM per volt. This would do 1000 RPM. Okay, to say I put a 2 volt motor on it, it's capable of 2000 RPM because it's a 1000 kV motor. But I don't have such small batteries. I've got bigger batteries here. Okay, so this is a 12 volt motor. If this is 1000 kV, 12 volt by 1000 is 12,000. So 12,000 RPM it would be capable of, which is not terribly high for a brushless motor. So again, 12 volt battery, 1000 kV, 12 by 1000, 12,000. If this was a 2000 kV motor, that would be double. Instead of 12,000 RPM, it'd be 24,000 RPM. Capable of that. That's, you know, theoretical. But it tells you what the kV means of a motor. So if I'm spinning quite a large propeller, I'm going to have a fairly large motor, fairly low kV, maybe 800 kV. But on my little drone that I might have, they might have small, very high kV motors. Which brings us to this one. This is a ducted fan. Okay, kind of like a jet. Difference is it's just an electric motor, brushless motor. There's my 3 wires again. There's my fan. There's no compressor and turbine. Okay, it's just a high kV motor spinning this fan, it's a propeller, we'll call it a fan, at high RPM. So this might be a 3000 kV motor powering this. Again, if I put a 12 volt lithium polymer battery on it, 3000 kV motor, what will be the theoretical top RPM? 312s of 36,000 RPM on this particular one. Okay, not much torque at all, plenty of high speed. So if this was on my aircraft, it would be hard getting it into the air. I'd need a fair bit of speed, perhaps a bungee launch or whatever to get it into the air. But once it got going, it would go really fast. Ducted fan. Not a jet, but kind of looks like it. They sound like a Hoover. Okay, so different motors, brushless motors there. This is brush DC motor. Okay, you can see there's just, from the speed controller, there's 2 wires. So you would not have a brushless speed controller. You'd have to have a brush speed controller, which would have 2 wires coming out from it. This has got a gearbox on it. Okay, to gear it down to spin a large propeller. And the insides of it, there's, okay, I'm not going to be able to pull that apart. There we go. There's a part where the physical brushes, just here, these things here called the brushes, touch the part that spins around. Okay, and switches the power one way to the other as it spins. So the propeller's continually turning in the one direction, but they're separated through here. You can look up your brush DC motor theory. You've got your magnets in there again, but you've got physical contacts inside. And so those brushes wear down over time. And you have a look inside and you can see lots, you know, arcing little sparks and stuff happening. So you've got a lot more heat being generated by that physical contact. Don't use them nowadays. Now, it was a nice motor in its time. It's now spinning a large propeller through the gearbox. But nowadays, I can do the same thing with a brushless motor. There's a little bearing there, spinning a large propeller if I want, or if I've got some sort of small racing device, I can put a smaller propeller, have a higher kV motor on it. Okay, remember what the numbering means. Okay, the first 4 numbers is stator diameter and height. And the last 2 is, last numbers are the kV of the motor. You know, you'd be looking at like 800 kV up to, you know, 3000s, depending on what you want to use for the motor. Brushless motors.